this will be a good walkthrough on how to get a station agent set up. The thing that I want to look at is going to be learning objectives. So I want to cover a little bit about the NCSLI 141 committee and the taxonomy that we're working on. Right now, and this is going to affect Scott quite a bit, but right now we're going through metrology.net and we're going through and grabbing all the taxonomies and making our taxonomies in metrology.net standardized on what the MII committee has came through and made as the official taxonomies, or what we're going to be proposing as the official taxonomies. So some places in metrology.net, we were doing things like AMPS DC, and that's getting changed to current DC, and things like AMPS AC is getting changed to current AC sine wave, because we need to know the shape of the waveform that we're generating as part of the taxonomy for that. So we're going through and implementing into metrology.net all the taxonomies that people are agreeing on. And I think over time it'll make the product a bit more powerful. So I'm going to cover a little bit of the object-oriented power for the programming as well. And you can see in here how some of the things we do when we're building the procedure automatically roll up into the user interface, to where the user interface can look at things in the code, and that's how they generate the UI, is based on the .NET reflection that sits in the drivers and how the properties and attributes get set to come up into the UI. And then I'll cover just a little bit about testing and running metrology.net. I'm not really set up to do actual any runs today because I got my equipment doing other tasks. So real quick about CalLab Solutions, so everybody knows who we are, so don't need to hit upon this very much. I do like to hit this slide here every time and talk about the better, cheaper, faster, and the fact that that's what we're trying to do with this automation. And it doesn't mean that we have to get, that we can't be getting better and cheaper at the same time, because that's where we're going to get our competitive advantages. This time we'll come in and talk about the problem statement, and the problem statement is that the configuration of the station agents becomes a little bit more complex. It takes people a while to wrap their head around the fact that metrology.net can run multiple calibrations at one time. So inside of the DC and low area, we're typically running 1 voltmeter at a time because we've only got one calibrator. But if we're in that situation where we have a voltmeter, or we've got a multimeter in our station and a calibrator in our station, that we can actually use that multimeter to do work at the same time with metrology.net. So that makes the setting up and configuration of metrology.net a little bit more complex. And we've ran as many as 3 simultaneous calibrations at the same time. We didn't see any decrease in speed running the 3 things that we were running as far as running them individually, but we ran out of equipment, so we couldn't test it at 4 and 5 and 6 calibrations to see where things slow down. One thing to point out is, as we're moving away from GPIB into TCP/IP communications, one of the limitations we have is how many GPIB instruments we can connect to a workstation. But as we're moving out of the GPIB world into LAN communications, there's no limit to the amount of LAN instruments we can have connected. So we can start seeing more work being done on our workstations as we do our LAN configurations as opposed to GPIB. This testing scenario we're going to put together is we're going to set up a DMM workstation, and we're going to set it up using a 5730, and we're going to put it up around a 34401 test. And the standards we're going to use is going to be a Fluke 5730 4-wire short. And actually, I forgot to update this. We're going to put in here an Agilent 33250. So that didn't make it back to this slide, but it's in the rest of the slides. Typically, when we're setting up our station, we have our stations where we can just copy in the files, but we want to make sure that we have the station agent, the metrology.net, the services, the message services DLL, the .NET reflections in there, and then the drivers. So we got to have our Fluke 5730 driver. We have to have our Agilent 33250 driver, our UUT test point controller, and our UUT DMM. So as we're putting in our station agents, so Metrology.net was built around the .NET framework. And one of the things the creators of the .NET framework wanted to get away from was the thing that they called DLL Hell. The problem is you'd have 5 or 6 applications installed into Windows, and it was sharing DLL resources, and you weren't sure which version of the DLL you were running. So that's why they were calling it DLL Hell, was getting all those DLLs updated. Windows would kick out an update, and their update would break your DLL, so you had to put another DLL in to do the things you needed to do. What they started doing with the .NET is .NET has this ability that it's going to look locally inside of your directories for the DLL. If it doesn't find the DLL it's looking for or needed in that directory, then it's going to go out and look at your Windows typical shared directories for the resources they need. So it gave programmers the ability to localize and get a little bit more control over their application by putting that DLL that you wanted to use with the .NET framework inside of that directory. So it solved a lot of problems. So one of the advantages you have with a .NET application is you don't have to do a full-blown install. All you have to do is copy in your files. Now that does come with a consequence on some of the stations that the IT says we're not going to allow just copy DLLs to run. So you'll have to go through and individually add the DLLs and allow them to be executable. But once you get that done, you're set. You can simply grab your station agent files and just copy them into a directory. And we prefer people to put everything in the C:_station agent. The first time you come in and you're setting up a station agent on that computer, the station agent needs to make an entry into the registry, and it's going to want to write your .dat files. So you need to start it as administrator if you don't automatically have these administrator privileges. So we tell people to go ahead and click the station agent executable and run as administrator. And that will start it up and give it more privileges into the workstation. First step we have to cover is we've got to go into the station configuration. So we're going to go under Configure Station, and it's going to pop up this screen. And inside of here, you see this guy's grade. So that's going to list the name of that computer. If you want your computer name to change, you have to go back into the control panel and go into your system and change the name of that computer. Then you want to reach out to your server. You want to put your server in and your workstation login. I tell people all the time, don't use the same login and password you use for running the calibration. Have a station agent login and password in there. And what that does is makes that station's connection unique to the server. And we run a lot of security. When the station logs in, it gets an ID, and we pass that ID with each one of the measurements, so it knows exactly which station wrote that data when and where. The other thing you have to check is click on the mode and make sure the metrology.net is checked, and then hit save. Once you've saved that, we're going to come back in and start the services. So by going to File, Local Agent, Start, that's going to start the station agent. And it's going to put down into the right-hand corner of your computer, it's going to put the metrology.net running as a service. And that's what's actually doing all the work. You could close the executable after that, and the service is still running. it's going to need to open up on your computer. And this is another reason you want to be in administrator mode, is it's going to want to unlock on your computer the local host port 13212. And it's using that port to run all of its communications between the configuration and the service that's running. So the configuration application is actually remoting in to the station agent and configuring that local station agent. And then you'll see it start up like this. It'll say station agent, and then you'll have instruments, drivers, and test processes. You'll have those set up, but there'll be nothing in there to configure. A little bit about the Metrology Taxonomy. If you've ran out to the metrology.net site and looked at the taxonomies, this is where the MII group is keeping the official list of the names and the parameters that we're agreeing on. There's two links in here. So there's the HTTP Wikidot, which has a bunch of information. I'll grab these and chat these out to you guys so you have them. That way you can reach out and grab those and look at what the group is doing. There's a lot of really good information out there about what the group is doing, and we're meeting once a week on Mondays to expand and put out more information. We just finished up mass calibrations, and now we're moving into length metrology. So we're working on getting all of our length metrology is going to be the next area that we're working on adding to this list. The next thing I want to talk about in here is going to be setting up the station and how we put these together. So we're going to need to add all these test processes. So we're going to need to add the current processes for AC amps and DC amps. We're going to need to add resistance. And one of the things the group worked on was we changed resistance from being 2-wire to 4-wire in the Metrology Taxonomy to making it just resistance, and how it's connected, 2-wire, 3-wire, 4-wire. That's just a function of what the connector is. So we didn't want to create a different taxonomy for each one of the different wire configurations. So that was one of the changes that we made inside of the group. So then we want to add our AC voltage, DC voltage, and then we're going to add our test process for our frequency, because our multifunction calibrators aren't accurate enough to do frequency a lot. And then we're also going to add in a test process for our 4-wire shorts, so that we have that in there so that we can use a 4-wire short as opposed to 0 volts out of our calibrator, because that may not be accurate enough to do our tests. And then we also have to set up our UUT measure Visa script controller. So as we're setting that up, that's going to show how our unit under test configuration is a little bit different. So I want to touch upon real quick how we're doing our driver overview. And this is just how CalLab Solutions decided to build our drivers. We have this hierarchy of drivers where we have our test process. We're going to have our metrology source driver. Then we're going to have an instrument driver that holds that instrument state. The reason we do this is so we get more reuse out of code. We write a little bit extra code, but by having these design patterns, we get a lot more reuse. One of the examples that quickly comes to mind is a 5790 will only measure AC voltage, but we only have one measure AC voltage driver, and we can use the test process to call that measure AC voltage driver with a current shunt to generate current measurements for us. So something we wouldn't be able to do with just having a flexible driver format. To configure any one of the instrument drivers, you're going to come in here to add instrument, and then it's going to pop up a screen here, and you're going to scroll down to the instrument driver that you're adding, and then you're just going to simply press the add button. A couple things to note is over here we'll have a little bit of a description. It'll tell us if there's a unit of measure that it covers that's specific. So when we get into our measurement processes, you'll see that. You can also see the revision date and an ID of the organization that created it. As we're kicking through these, you can look at these descriptions and that'll help you figure out what you can run. So here you can see a 5700 series driver. We've tested it against a 5700 AEP, 5720, and 5730 multifunction calibrators. So we know that it works against all of those instruments. So we'll try to put good descriptions in there so people can get an idea of what they need to add with their drivers. Once it's added, then we're going to come in and add additional information. On our Visa resource dropdowns, you're going to see that Visa resource dropdown. It's going to scan the bus now, and it's going to give you all the instruments and all the Visa resources that are on your bus and put it in that dropdown. So that makes it easy when you're coming in doing your configuration that you don't fat finger and enter a Visa resource incorrectly. Then you can put in your serial number, your asset ID, your cal due date, your calibration date, then press the update button and that data will be saved. Then after that, we got to come back in and add the additional drivers. So we're going to come in and add our 33250 driver, and we're going to add our UUT Visa script driver. Now you'll notice down in here that we've got this measure dynamic controllers that are in there. There's still some procedures out there that use that functionality, but we're trying to move all of our test packages over to the Visa script because it's simple, and with metrology blocks it's even simpler. And that dynamic is now going to pop up and show you that we're deprecating it. So we want you to move away from using those and focus on building test packages with the Visa script. Once those guys come up, now you can come in and configure all the items. So a UUT test point controller, right? It doesn't have any cal due dates and any information like that because it's designed just for the unit under test. And that's one of the things that's happening is this user interface. This is dynamically built based on what properties that driver wants you to set. So as we're building more and more test processes and drivers, we can add or take away to what we're putting in there. And I'll cover that in a little bit more detail later as to how that works. Then you hit update and that's configured. So now you can see that we've got this much of our metrology process configured. We got our drivers for our standards, and we've got our UUT base driver. So the next thing we want to do is start configuring our metrology specific drivers. Now you can see that we want to start adding our metrology drivers. So you're going to come into add driver. You're going to scroll down to where you find the 5700 driver that you want. And each time you click on one of these, you'll see this change. So we're adding now the source amps for a Fluke 57X driver. So we're going to add that in. But you can see that if we clicked on different ones in here, we would get different configurations that would come up on what they're doing. So we press the add button, and that's going to bring that up to where now we've got our driver and we want to come in and configure it. And we got to repeat that process for our 33250 source volts AC, then our DC current, our AC current, our 4-wire resistance, our voltage AC, and our voltage DC. We got to come in and add all of those drivers until we get our driver profile looking something like this. Once we have all of our metrology drivers configured, then we have this much of our process put together. Now we can move on to the highest tier of our metrology processes. And the difference between our drivers at the measurement process versus the metrology process, the difference between those two drivers is one of them is designed to iterate through a list of test points, organize our test points, and give us connection messages. The other one is designed to make a measurement and make that single measurement very specifically, very precisely, and to the highest accuracy that device can be employed. So now as we're coming in, adding our current AC sine wave, again, you can click on the different ones of these configurations, and you can see the measurement change, so you can pick the ones that you want. So you may want to run straight up calibration. You may want to adjust the calibrator until the meter reads a certain amount. You may want to run a process that's characterized to where we've taken that 5720 and characterized it with the 5790, and now we've got characterization data on it. So you can pick the process you want to add it, and then you come in and repeat that again for all the different test processes until you have something that looks like this. So you've got your adjuvant for source frequency, then you've got your current AC sine wave, current DC, resistance, voltage AC sine wave, voltage DC on our short for our DMM. And now that we're at that process level, our process level wants to know what's the metrology process driver it's going to use. And then it also wants to know what's the UUT driver that it's going to use. So you have to configure both of these and then hit update. And you can also see in here that you can set the number of readings you want to make, and if you want it to store all the measurements on the server, or if you want it to store just the average of the measurements if you're taking multiple measurements. And when that's complete, we have configured all of our Metrology.net drivers, and we're ready to come in and actually calibrate something. So we can immediately open up make sure the work order is assigned to our workstation. We're in the test run mode that we want. Then we can hit the run button and we'll see our configuration in the test processes that we just configured and hit change and run and start that calibration process. Now a real quick look underneath the hood. We can see here how this UUT driver and the code that goes with it, that it'll only let us put in a piece of code that is I measure test point controller is the only thing we're allowed to put in there. So if we have only one of those drivers configured, it'll give us one. If we have two of them configured, it'll give us both items on the dropdown. This is what allows Metrology.net to configure two 5700s inside of a workstation. So there may be a time when you want to use two 5700s together to calibrate something like a Yokogawa power analyzer, or you could run two voltmeter calibrations at the same time with those two 5700s configured inside of that workstation. And we can add to this, so this type equals definition in here with our attributes, we can put a comma and put multiple types in there. So we may have a generic process that will let us use a 5700 or a 5500. We can put both of those in there and allow several processes to be called. And that's what populates this dropdown. And it's all being done by this attribute tag that sits right here over the property. So that attribute tag takes that property and says when we have that property in our driver and we want to put it up on the UI, it just auto-populates everything for us. And that's kind of where the power of object-oriented programming comes in, is we make this connection between our process to our specific process very dynamic and addable at runtime. When we create a new Metrology.net DLL and drop it into that driver's directory, the system is able to use .NET Reflection, grab that data, and present all of that code up to Metrology.net so the station agent can now configure it. So anything you want to put into your configurations that you want to make settable at the workstation or settable when the procedure runs, you can do that very, very easily just by how you're running your attributes. A couple other ones to cover here real quick is you saw on the drop downs, right, that we had things that we could see. So I put in here over the manufacturer that it's an adjuvant and it's not editable. So now the user interface is going to come up and say, hey, you can't edit that. That's not an editable property, so you can't edit that. Okay, but down here under the cal date, I say that it's editable equals true. So now the user interface says, oh, we're going to allow people to edit that value. Here under the properties, I can say that it's editable equals true give it a list of it can be internal or external, and it's limited to the list. So now you can only set it to internal or external. You can't set it to any other value. So that makes it to where we can come in and configure those drop downs very easily, very flexible. And we can use .NET reflection capability to expand and make writing Metrology.NET processes much easier, to where the user doesn't have to worry about how to configure all the things for the user interface, whether we want to move it to the station agent or bring it up into the web UI. So I think we cover all the learning objectives in here, where we hit the Metrology Taxonomy, object-oriented programming, a little bit about .NET reflection and attributes, and then how you run tests in Metrology.NET. Any questions?
Yeah, I have a question. Once we configure a station agent to run on one computer, is it possible to copy it over to another computer and then just change that one computer name, like from DP500 to DP501 or whatever the IT department decides to call it?
Yeah, I'm working on that in Metrology.NET in the 2.0, to where when you move them over, I'm going to add a thing that says you can go through and rekey all your processes, and it'll go through and just assign new reference IDs to everything.
Right. Because I mean, that's the issue that I have. Anytime I move it, anytime I set up a station agent on a different station, I have to go through that whole process each time.
Yep, and I want to add another thing that allows you to keep multiple configurations. So you could go in and change a configuration, and then you can move it from, I want to do 5700 work, to where I want to move it to 5500 work, and you can just change that configuration. And we also want to add in a wizard that'll make it faster to go through and configure things.
Right.
So, but we did notice that as one of the things that makes it really slow when you're coming in doing your configurations. As well as once we get that configuration put together, then you can come in and say, I want to calibrate it like this, grab another configuration, bring it down, right? And then just be able to rekey it for your workstation and be done.
All right. Now, another question I have is, if you release new drivers, would I have to go back and rebuild the station agent using the new drivers?
Yes, you'd have to go back in. If the names of the drivers change, then it doesn't know how to find those. And we have done some changes to the driver names. So we're naming the drivers according to the taxonomy, so that AC voltage, AC and DC voltage have been drastically changed. AC and DC amps have been drastically changed. The other areas, it's very minor, but yeah, we'd have to go back in and reconfigure those stations.
Yeah, what I've been doing is, like say for instance, on the station that I use to calibrate calibrators, I'll keep what I call a stable version of it going. And if I see that there's new drivers updated, I'll grab a laptop computer or something, set up like a beta test station agent on that one to try it out. So that way, in case we get a rust job comes through the door, I can go back to the stable version and use that.
Yep. So you can grab your station.config and copy it and then name it. So I'll have like an underscore multifunction calibrator station config.dat. So all I have to do is just replace my config.dat with that one, and now I'm back up to how it was running.
Right.
So that's typically how I will do it. The other thing you're able to do is you can keep multiple directories. So you could keep directory A, directory B, directory C, and then just start it from that directory. It will only scream at you when you try to run two services at a time. So does that answer your question, Scott?
Yeah, pretty much. At least it gives me some better ideas. I could probably have like a stable version in one directory and have like a beta test version in another directory instead of having two different laptops.
Yep.
Does the station agent do any backup to the to the server of that config file? If your computer crashes, you can pull it back down, or do you have to do that backup manually yourself?
You have to do the backups manually yourself. One of the things that we wanted to add into the station agents was they could be remotely configured from the server. And once we make it to where they're remotely configurable, then we could actually start doing backups to the server on the files and the configuration.
Right, okay, cool.
So any other questions? Okay, great then. I'd like to thank everybody for attending this automation lunch and learn on World Metrology Day. Thanks, and everybody take it easy. Bye.